How do stars live and die?
The way stars live and die makes a lot of sense if you consider what a star really is. Simply put, a star is a large amount of gas and dust that is collapsing under the force of gravity. At first, this crush of gravity makes the inside of the star hot enough to ignite a nuclear explosion. This explosion supports the star against gravity and makes it shine. In our Sun's case, this stage will last for about 10 billion years. But eventually, all the nuclear fuel inside the star, mostly hydrogen and helium, gets used up. After that, there's nothing to support gravity, so once again, the star starts collapsing. What happens next depends on how much mass the star had in the beginning, and which forces of nature can finally hold up to the crush of gravity. With stars about the size of our Sun, gravity will crush everything tightly together, but eventually, the structure of the star's atoms will hold up gravity. Those stars, like our Sun, will become white dwarf stars. A white dwarf is basically a big dying cinder about the size of the Earth, and with a density of an 18-wheel truck crushed into the volume of a sugar cube. If a star is just a bit more massive than the Sun, not even the structure of the star's atoms can hold up against gravity, and everything gets crushed into one giant atomic nucleus. This forms a neutron star, which is about 10 miles across and has a density of a Mount Everest per sugar cube. If the star is much more massive than the Sun, say about 3 times more massive, then nothing can hold up to the force of gravity. The star collapses right out of existence and becomes a bottomless pit that we call a black hole. Nothing can escape the gravity of a black hole. In fact, the reason we call them black is that the gravity is so intense it can actually pull in light itself. So, the final death of a star depends on its mass and what, if anything, can stand up to that final crush of gravity that began even before the star started to shine. For Ask an Astronomer, I'm Dr. Michelle Faller of the Sort of Science Center.
What is a brown dwarf?
We know that stars are common in our galaxy, and we assume planets, moons, asteroids, and comets are too. But if you were to take a cookie-cutter slice of the Milky Way galaxy near the Sun, are these the only objects you'd find? Believe it or not, the answer is no. There's a kind of object known as a brown dwarf that's at least as common as your average star. These objects form the same way that stars form, in a collapsing cloud of gas and dust, but they're unable to shine for billions of years the way stars do. Brown dwarfs also have traits in common with planets. Oddly, all brown dwarfs have roughly the same size, about the size of the planet Jupiter. Also, as brown dwarfs cool, they begin to develop complex atmospheres with clouds of methane and, in the coolest cases, water. So in that respect, they also resemble planets. However, planets are formed in a disk around the star, quite unlike the birthing process for brown dwarfs. So brown dwarfs are like stars, but not really. They're also like planets, but not really. They're the duck-billed platypus of the cosmos. The platypus defies easy classification as either a mammal or a reptile. Brown dwarfs defy classification as either a star or a planet. So, how did brown dwarfs stay hidden for so long? Brown dwarfs continually cool with time after they're born, so they don't emit very much light. Because they're so dim, they're very hard to detect, even when they're relatively close. However, what little light they do emit is concentrated at infrared wavelengths, which correspond to colors redder than your eyeball can detect. Astronomers have developed new detectors, infrared eyeballs if you will, that show a multitude of brown dwarfs that were hidden to our eyes. Quite amazingly, astronomers have uncovered hundreds of these objects in the neighborhood of the Sun, and we now believe that in our own galaxy, there are twice as many brown dwarfs as there are stars. For Ask an Astronomer, this is Davy Kirkpatrick of the Infrared Processing and Analysis Center at the California Institute of Technology.
Why do we see spiral arms in some galaxies?
Spiral galaxies get their name from the shape of their disks, in which clouds of stars that we call spiral arms extend outward from the central nucleus of the galaxy. These apparent structures are caused by gravity. The gravitational force from the galaxy's core causes all the stars in the galaxy to rotate around it. But the stars themselves are also strong sources of gravity. Stars in the outer regions tug on the rest of the galaxy. As stars move at different speeds around the galactic center, they feel each other's gravitational influence, like the wakes from ships passing in the ocean. In many galaxies, the wave is in a spiral shape, and this spiral moves through the stars and clouds, disturbing them. So why are the spiral arms so much brighter than the rest of the galaxy if they're just being tossed by a wave? When a gravity wave passes through a gas cloud, it squeezes the cloud. Dense clouds of gas and dust collapse and form new stars. The band of younger, brighter stars becomes visible to us as a spiral arm. Many galaxies have a spiral structure, but depending on the angle we see the galaxy from, this structure may or may not be visible from Earth. Over the years, astronomers have obtained spectacular images of spiral galaxies, helping us better understand both the distant universe and the galaxy in which we live. For Ask an Astronomer, I'm Dr. Steve Floyd of NASA's Infrared Processing and Analysis Center at the California Institute of Technology.
How can we see a black hole?
A black hole is one of the strangest objects in outer space. For one thing, a black hole is not really a hole, and it's not empty. It's actually filled with a lot of material crammed into an extremely small space. Scientists think that black holes are created in places where the force of gravity crushes an enormous amount of matter together, making it incredibly dense. This can happen in the centers of large galaxies, or when a giant star collapses and shrinks during the final gasp of its short yet brilliant life. Like the tug of gravity on Earth, a black hole exerts the same kind of force on its surroundings. But with these fantastically compact and massive objects, the gravitational pull is so strong that even light can't escape. That is why the object is black. It does not give off any light. It's as if you were looking at a black hole. So we can't see black holes directly. However, we can see the effect that they have on the region of space around them. Since black holes have extremely high gravity, the surrounding material, like gas and dust, is funneled into a disk around the black hole. The gas atoms in the disk swirl around the black hole so fast that they heat up and emit X-rays and even higher energy light. By finding this very hot material, which is spiraling into black holes, astronomers can locate them and study their properties. So astronomers study the motions of objects in space to see where there is material that might be moving, as if a black hole were affecting it. The motions of stars would be most unusual if a black hole were nearby. So far, evidence has been found for the existence of black holes in the centers of several large galaxies and in binary star systems. That's where two stars orbit each other. And yes, there's even a very large black hole at the center of our galaxy, the Milky Way. But don't worry, the black hole in the center of our galaxy is much too far away to be any danger to Earth. For Ask an Astronomer, I'm Dr. Tom Jarrett at NASA's Infrared Processing and Analysis Center.
What is the nearest galaxy to the Milky Way?
It seems it should be easy to answer the question, what is the nearest galaxy to the Milky Way? But in reality, it's a little complicated. One way to answer the question is that the nearest galaxy to us is the Andromeda Galaxy. The Andromeda Galaxy is a large spiral galaxy, much like the Milky Way. It's located about 2 million light years away from us. If you look in the constellation Andromeda, you can actually see this little fuzzy blob. That, in fact, is the galaxy, and it's the farthest object you can see with your naked eye. The Andromeda Galaxy is the closest, completely separate large galaxy to the Milky Way. But, there are other ways to answer this question. The Milky Way actually has two small, blobby galaxies that orbit around it, sort of like moons around a planet. These dwarf galaxies are called the Magellanic Clouds, and they're very easy to see if you happen to be in the southern hemisphere. The Large Magellanic Cloud is about 160,000 light years away. The similar but slightly smaller Small Magellanic Cloud is about 210,000 light years away. But it actually gets even more complicated than that. In 1994, astronomers discovered that a dwarf galaxy is actually colliding with the Milky Way right now. This little galaxy is currently about 88,000 light years away from us in the constellation Sagittarius. Then, in 2003, astronomers found another dwarf galaxy in the constellation Canis Major. The Milky Way has almost completely eaten this little galaxy up, but the center of this disrupted, smeared-out galaxy is only about 25,000 light years away from Earth. There's no danger to Earth from any of these collisions, but it's interesting to note that we're actually slightly closer to the center of the Canis Majoris dwarf galaxy than we are to the center of our own Milky Way. For Ask an Astronomer, I'm Dr. Michelle Thaller at the Spitzer Science Center.